Okay, this is the lecture video for MAC 1140 pre-calculus. In this video, we're going to be covering sections 12.2, which goes over arithmetic sequences, as well as section 12.3, covering geometric sequences. So we begin with arithmetic sequences, first with the definition. The way that you tell whether or not you have an arithmetic sequence, a sequence is a list of numbers. And if you want to know if it follows an arithmetic pattern, then you have to check the difference between successive terms. And if that difference is always the same, no matter what two successive terms you use, two successive terms would be any term minus the value for any term minus the value of the term right before it. So that's what two successive terms means. And if that difference always comes out the same, then we call it an arithmetic sequence. Finding out or discovering that it's an arithmetic sequence then allows you to use the formulas for arithmetic sequences, such as finding any specific term in the sequence. You could be asked to find the 10th term, the 50th term, the 100th term, and this formula gives you the opportunity to do that. So finding the nth term in an arithmetic sequence, we call that a sub n. And if you're finding the 50th term, you would just call it a sub 50. Whatever the n value is, the value of the term that you're finding, that would also be plugged in here. So if you were looking for the 50th term, that would be equal to the first term plus 50 minus 1 for the 50th term times that common difference that occurs between terms. Now, I want to make a comment that arithmetic sequences, they are considered recursive sequences. And if you recall from the previous section, 12.1, recursive sequences is any kind of sequence where a specific term can be calculated based on the term that occurs before it. And that is true of arithmetic sequences, that any term after the first is calculated based on previous terms, which is kind of indicated right here in the formula. Okay, so let's take a look at the types of problems that will allow us to use this formula. We're also going to be moving into finding the sum of a certain number of terms in an arithmetic sequence. We'll be introduced to that formula, but right now let's take a look at some of the types of problems we can do with this formula. Now in example 1, you don't really need a formula because it's just too basic. All they're saying is fifth term of an arithmetic sequence is 11. So the fifth term, just to give it a name, happens to be 11. The value in the fifth position is 11. There's 4 terms that come before it. First term, second term, third term, fourth term, but this only concerns the fifth term, and they want to just know what is the term in the sixth position. So that's the question. What is the value here in the sixth position? But they've told you that the common difference is 4. That means this minus this is positive 4. So if the difference between these two is 4, to get to the next term, the sixth term, you can just simply use a positive 4 combined with that 11. Notice that the common difference that they referred to as being 4, that would be appropriately applied here because 15 take away 11, that's what the difference is. 15 take away 11 is 4. And you can use it going forward, but typically when you calculate it, it's just the value of any term minus the 1 in front of it. Okay, so the answer to this question, what is the sixth term? 15. Example 2. In example 2, they give us the rule that has already been devised for finding any term in an arithmetic series. And they say the first term is what? So you're looking for the first term. So if you want to find the first term, this rule that has already been devised can be used for any term, including the first term. So you would write it like this. I'm finding the first term. In other words, n is equal to 1. I let it be 1 there, and therefore I should also be allowing the n to be 1 over here for the rule. This is the rule that covers finding any term in the sequence. So negative 7 times 1 plus 4, that turns out to be negative 3. And so the very first term is said to be negative 3. Okay, so moving on to example 3. Again, we have a formula that's already been devised. It's already been calculated for you, and the rule is 2n minus 3 to find any term in this specific arithmetic series. Now in this problem, they ask it in this way. They want to know what is the common difference, and they want you to list 4 terms. So the easiest way to answer this question would be to find these 4 terms using this specific rule to generate any of the terms. If you're finding a sub 1, that means the n value is 1. So it would just be 2 times 1 minus 3. That would be 2 minus 3, or negative 1. That would be your first term. If you're finding a sub 2, that means that the n value is 2. So again, using this rule, it would be 2 times 2 minus 3. So 4 minus 3 is 1. That would be your second term. If you're finding a sub 3, then n is equal to 3, which would be 2 times 3 minus 3. So 6 minus 3 is 3 for your third term. Then for the fourth term, it would just be, again, the same rule, 2 times n, but this time we're allowing n to be equal to 4. 2 times 4 minus 3. So that would be 8 minus 3, or 5. We have now found the first, the second, the third, and the fourth term. And to find the common difference, just take any term and subtract the one before. And I'm going to use these 2 positive ones. So 3, take away 1 is 2. And notice that that common difference is constant all the way down. Negative 1 plus 2, 1. 1 plus 2, 3. 3 plus 2, 5. And that is one of the properties or the characteristics of an arithmetic sequence. That once that common difference is found, it is constant between any 2 successive terms. Okay, moving to example 4. Find the nth term of an arithmetic sequence whose initial term and common difference are given. So what is the 75th term? Again, find the nth term. So for this particular problem, if they want a formula for the nth term, find the nth term of an arithmetic. Okay, so they want a formula excuse me, for the nth term, and once again, that formula is first term plus n minus 1 times the common difference. See, sometimes they want you to come up with a rule. This is called the rule for the nth term. We've been given that rule in the previous 2 problems. Like for instance, in this problem, the rule was 2n minus 3. Here the rule for finding the nth term was negative 7n plus 4. In this problem, we're coming up with it by ourselves. Let's write a little bit clearer here. I want you to be able to read my writing. That would help. Okay, so if we want to come up with a rule that finds any particular term in the sequence, it would be the first term, which is negative 8, plus n minus 1 times that common difference. And we're coming up with our own rule for finding the nth term. So it would be negative 8. This 5 can be distributed, giving you 5n minus 5. Positive 5n minus 5. And that simplifies when you combine negative 8 and negative 5. That's negative 13 with a 5n as well. So there is the rule that we can use to find the 10th term, the 20th term, and then more specifically what they're asking us for in this problem, which is the 75th term. So the 75th term just means that in this rule that we created ourselves this time, we're going to be using n equal to 75. So 5 times 75 minus 13. And if you put that in your calculator, you get 362. Okay, so we did two answers here. We found the rule ourselves that would generate any term in the sequence, and then we used it to find the 75th term. So this is a type of question where they'd be asking for two different responses. Okay, so this would be one of the answers. This would be another answer. In the problem above, we got 4 specific terms, and then I just chose any two. I just happened to choose these two. Not that you would get a different answer if you chose those two. And I found the common difference. That was another question that they needed an answer for. Okay, moving on to example 5. And in example 5, it says, find the nth term of an arithmetic sequence whose initial term and common difference is given. So again, we have the first term, we have 1/2. And I'm going to be basically doing the same thing. I'm going to be finding a formula for the nth term, and then I'm going to be looking for the 43rd term. Just some extra practice. This one just happens to have, a fraction. Okay, always write the formula down first. Number 1, so you can get familiar with them and so that you can focus on what you're plugging in by looking at the formula and then plugging those items in. First term is 9. It was given. Common difference, 1/2. And you can use a 0.5 there if you're more comfortable plugging that into the calculator, which I think I will. So this is going to be 9 plus 0.5 times n. Same thing as 1/2 n, just easier to put to a calculator. And then -1 times 0.5, -0.5. If you combine like terms here to come up with a more simplified rule, you would have 9 take away 0.5 or just 8.5. And then we have the n term. So I'm going to write my n term first. And then combining the 9 and the -0.5, I would have positive 8.5. And that would be the rule that I could basically use to find any term I wanted, just like in the last problem. So I'm going to use it to finish answering the question here. So I came up with a rule that would work for any term, and now I'm using it to find the 43rd term. So it's 0.5. Remember, announcing that you're finding the 43rd term means n is 43. So it's 0.5 times n, using this rule, plus 8.5. And then going into the calculator, be 0.5 times 43 plus 8.5. And you get 30. Okay, so two answers there. Coming up with our own rule, just like we did in the last problem, for finding any term in the series. And then here we found the 30th term. Okay, number 6, we'll find the 80th term of the arithmetic sequence. So now they don't come straight out and tell you what the first term is or what the common difference is, but you can very easily see what the first term is. So it's really not much different than what we did in examples 5 and also 4. So the first term you can clearly see in the series is 3 in the sequence. And common difference, that's pretty easy to find also. Just take any term and subtract the number before it. And you have your calculator, so that's very easy to do, even if it's fractions. So I'm going to go 10/3 minus the number in front of it. Okay, don't forget to hit, instead of equals, hit math, enter, enter. And it'll convert it right back to a fraction again. So instead of equals, hit math, enter, enter. Okay, so 10 divided by 3 minus 3. Math, enter, enter, 1/3. So that common difference is equal to 1/3. So if you were going to find the 80th term, remember that you can use this formula. A sub 1 plus n minus 1 times the common difference. That's for finding any term that you want, and we could jump right into finding the 80th term. This just announces that we're finding the 80th term. Right here, we'll put the value that's in the first position. We're going out to the 80th term, so n is equal to 80. Common difference, 1/3. Okay, so this is going to be 3 plus 79 times 1/3. Okay, and go ahead and put that in the calculator. Press it in just like you see it. And I'm actually finding the value already. So this would be 3 plus 79 times 1 divided by 3. And I'll just hit math, enter, enter, since one of them is a fraction. And I get 88/3. And then you know if they do want you to come up with the generic rule for finding the nth term, you could just, without going directly to the answer, as I did right here, you can keep it in formula style. And I have done that for the last two problems. So if they do require that answer right here, you would just go -8 plus n minus 1 times the common difference. This just gives you a generic rule that you could either plug into the generic rule, or you could plug right into this formula right here without coming up with the rule. You could just plug in the first term, you can plug in the n value, put that common difference, and go right to the specific value. But if you are trying to generate a formula, as I did in examples 4 and 5, then you stick with this n formula right here, and then just try to clean it up a bit. Like this would be -8. You would carry the 1/3 through. Don't convert it to a decimal because that's a run-on decimal, and it's not going to give you an exact enough answer if you round it off. You can only turn it into a decimal if it is a terminating decimal, one that doesn't run on and on. Okay, if you wanted to clean this up a bit, it would just be -1/3 n, and then you could combine in your calculator -8 minus 1/3, just to give a cleaner type of rule. -8 minus 1 divided by 3, math, enter, enter, and that would be -25/3. Okay, let me make sure that I did that right. I have actually, I think I plugged in, let me see, what did I plug in for the first term? This I have to fix. So let's fix that real quick. A sub 1 should have been 3, and I accidentally plugged in -8. So that should have been, let me fix that. That should have been 3. Therefore, this should have been 3. Glad I caught that. Okay, so that would have been 3. Then this would have been 1/3 times n, 1/3 n. And that would have been positive. And a couple of mistakes there. And then 1/3 times -1 is -1/3. Okay, 3 plus 1/3 and minus 1/3. So let's clean that up again. So this should have been, sorry about that. This should have been 1/3 n. That was my n term right there. And then if I combine 3 minus 1/3, let's do that again. 3 minus 1 divided by 3, math, enter, enter. So that should have been actually 8/3. And that was Just a generic rule that actually could have gotten us this same answer. So there's several problems like that where you're coming up with a generic rule for the nth term, and then you can plug in whatever value. So if I wanted to get that 88 over 3, like I said, I can directly plug into this, which I did, and I got the answer. I plugged in right here, or I could have plugged in the 80 right here and gotten that same answer. Okay, moving on to example 7. In example 7, it shows that the 7th term is 9, the 20th term is 61. What is the first term of the sequence? What is the common difference? What's the recursive formula for the sequence? And so forth. Okay, so we're going to answer all of these questions. So just kind of to give you just a little scenario of what's going on here. You're in the 7th position, 3, 4, 1, 2, 3, 4, 5, 6, 7. And when you get to this 7th term right here, in that position, you have a 9. And then you go out even further, and sitting in the 20th position is the value 61. So when they say, what is the first term, you can basically just use the formula that we've been using for all these problems. You can take this formula, nth term, that incorporates the first term, which we're going to solve for actually because it happens to be the question right now. And the rest of the formula goes like this. Okay, the formula for finding the nth term, which we have used in almost all of the examples thus far in this section, except for the first 1 or 2. Okay, so what this allows you to do is it allows you to take any term that you want. It's usually used for finding any term, but you can also use any term. Like if we wanted to, we could go, all right, I'm talking about the 7th term, and in that position there happens to be a 9. So I could say, okay, when I'm talking about n equal to 7, and if I wanted the value that really represents the number in that 7th position, I could replace it with a 9 because it is a 9. But then anywhere that I see an n here, I can put a 7. So this is just saying that the n value is 7. Okay, we don't know the first term yet, but we're talking about an n value of 7 and actually use the value in that position. So it's 7 minus 1. We also need the common difference here. So here's one way that we could get the common difference. We could go, even though these are not right next to each other, we can kind of come at it this way. We can go 61 take away 9, and then ask ourselves, how many positions are there between the 7th and the 20th position? If we're going from the 7th to the 20th position, there are 13 numbers in between there. 13 values. So what we could do is find the difference between 61 and 9, but then spread it out amongst 13 values. So we can go 52, this minus this is 52, spread out amongst 13 values, and that would mean that the common difference is 4. So we could come back right back in here, take that 4, and complete this formula, thus allowing us to find the very first value. So we could go first value, 7 minus 1 is 6, and then 6 times 4 is 24. So we have the first value plus 24 is equal to 9. So then trying to answer this question right here, what is the first term of the sequence? We're about to find that. I'm going to subtract 24 here, subtract 24 here, and I have the first value, which is negative 15. Okay, what is the common difference? Already found that. That turned out to be 4. I've already answered that. That's negative 15. And then they have set up another way for us to find, this is just a different way to find the nth term. What you can do is if you already know what the common difference is, you could just take any term, and to get to the next term, you just add that common difference. So it's just an alternative way to get the next term after the a sub n minus 1 term. What is the formula for the nth term? Well, the formula for the nth term, if I wanted to get a basic rule for the nth term, again, I could go right back to that formula that I used right here. Those can be used to generate, a rule that will help us to get any term in the sequence. So I could go right back to that. When they ask, what is the formula for the nth term? And I can put in negative 15 for my first term. Let me move this over just a bit. Negative 15 for my first term, which I answered right here. Sorry about that. And then I could go n minus 1 times that common difference, which is 4, and come up with a rule as I have in several of the other problems. Negative 15, distributing this 4 would get me 4n minus 4. And then cleaning that up a bit, you would have 4n, and then negative 15 combined with negative 4 would be negative 19. So that is what they refer to as a formula for finding any term in the sequence. Okay, so we did several of those where we were looking for one of those, what I've been calling the rule, that they call it the formula. Okay. So several answers there, finding the difference, even though they weren't right next to us, this had a little twist to it. They didn't have two numbers right next to each other, but I figured out how many values there were between 7 and 20, which was 13 values, and I just found the difference and spread it out divided it up amongst 13 values to find the common difference. So a little twist on that. And then I came back here and I was looking for the first term, knowing that the common difference was 4, and that the first, I used one of the terms, and I actually could have used this one also. If I would have used this 61, I just chose to use the smaller one. I could have put the 61 right here instead of the 9, but then my n value would have been 20. Okay, either one would have gotten me a first value of negative 15. I went with this value, saying that I was concentrating on the 7th term, n value of 7, which caused me to plug in 7 here. And then I actually used the value in the 7th position, which was the 9, and that's how I found the first term. Okay, so all of that for that problem. Okay, moving on to example 8. Let's see what example we're in. Yeah, example 8. Okay, so example 8, there starts to be some problems where they're asking you to find the sum of the first n terms of an arithmetic sequence. Okay, so make sure that you know what kind of sequence it is, because on a test we would have arithmetic sequences and geometric sequences mixed up. So you have to make sure that you know what kind of sequence it is, because there's two different formulas for arithmetic versus geometric. We haven't gotten to the geometric yet. So this is the formula for finding the sum of however many terms they tell you to find the sum of. A lot of times they'll say find the sum of the first 50 terms in the arithmetic sequence. So just whatever they're asking you for. And in this specific problem, let's say we start off with a sum that has in the first position a 6, then an 8, then a 10, and it goes all the way out to 80. we would like to figure out how many terms are in this sequence. So in this problem, what I'm going to do is I'm going to start with this formula. I would like to know how many terms are in this sequence. This is the nth term. I'm not sure how far it goes out, so I'm going to use this formula here. The nth term, one that we keep using over and over again. This is before I find the sum, because if I'm going to find the sum of however many terms, I'm going to be using either this formula right here or this formula. There's two different ways you can do it. You can do it this way, and I can explain to you when would you use one versus the other, or I can use this formula. I'm going to be using this formula right here because you need to know the first and the last term if you're going to use this formula. This formula is equivalent to this, but this is for when you don't know the last term. Okay, notice that there's no a sub n here. So when you don't know the last term, you should use this one. Okay, but when you do know the last term, both of them require the first term, so that's not what determines it. But when you do know the last term, then you can use this one right here. Okay, so just two different ways to find the sum. So I'm going to use the one where I know the first term and the last term, but I don't know how many terms there are. All I know is that in the last term, sitting in that position is an 80. I would really like to know how many terms there are. In other words, the n value. And that's what I'm going to try and accomplish by using this formula right here. I want to know how many terms there are in the sequence. So again, similar to what I did in example 7, I'm going to talk about the number that is in the last position so I can see how many terms it goes out until it hits that 80. So there's an 80 sitting in the nth position, in the last position. Not sure how many numbers out that is. I can see the number that's in the first position. That's a 6. Again, I don't know what n is yet. But I do know, let's see. I do know the common difference. And that common difference would be shown just by taking anything, any term in the sequence and subtracting the one before that. So common difference is 8 minus 6 or 2. So I also have that number. And notice that there's 2 between each of these. It's a consistent difference, which is why it's an arithmetic sequence. Plus 2, plus 2. All you need is 3 numbers in order to be able to check it at least twice. So what I'm going to find out right now is how many values are there before it gets to this 80, and therefore I'll know the n value so that I can finally answer the question of what is the sum, which, as I stated, I'm going to use this formula right here. All right, so 80 is equal to 6 plus 2n minus 2. You're distributing this 2 from the back to both terms in the parentheses. So 2n minus 2. Keep going with that, and you have 80 is equal to 6 take away 2. That's 4. We have a 2n term, and we have a positive 4. Taking 4 away from each side and bringing it to this side, we have 76 is equal to 2n, and then dividing by 2, we have n equal to 38. So I have now found out that there are 38 terms that occurred before they got to the 80. Okay, finally now I can answer the question, what is the sum of all these terms that started with a first term of 6, ended with a last term of 80, and transpired over the course of 38 terms? So finding the sum. the sum of all 38 terms. Now that I know there's 38 terms, I choose to use this formula because I do know the first and the value of the first and the last term. So the n, there are 38 terms altogether. The first term is 6, and the last term is 80. Okay, so this would be 38 divided by 2, and you can press it in just like this if you want, but I'm just cleaning it up a little bit. It's just easier to press it to the calculator. So this divided by this is 19, and then 80 plus 6 is 86. And then we're going to put all of that in, and the sum of all these terms, even the ones that you can't see in the middle, if you went this plus this plus this plus all these missing terms all the way up to the last term, even though that they're not listed individually, you would get 1634. Okay, so your first experience with doing the summation for a certain number of terms in an arithmetic sequence. I found out that there were 38 terms by working this formula that we had used repeatedly in examples 1 through 7, all the way until I found out what the n value was. Then I took that n value and plugged it right in here, divided by 2. I could already see from this sequence that was given that the first term was 6 and the last term was, the value in the last term was 80. So I really just needed that n, which is why I started off by using this formula right here. Common difference I was also really able to find very easily by just seeing this minus this is 2. This minus this is also 2. So that was very easy to get. Okay, moving on to example 9. Find the sum of the first 100 terms. We can see that in the first term there is a 14, and then it goes on and on and on. We don't know the last term. And I made comments above when I was giving you your 2 options for finding the sum of the numbers in an arithmetic sequence. I said use this one if you don't know what the last term is, and that would be this right here. If you do know what the first and the last term is, well, you're going to need the first term for both of them. If you do know what the last term is, which is called a sub n, if you know that value, you can use this shortened formula. But if you don't know what the last term is, then you're going to be using this. So you don't know the last term. It just has dots, but doesn't actually show you the value in the last term. So you don't know a sub n. Therefore, you cannot use the formula with the a sub n in it. So I'm going to be using this one. Okay, the sum of all n terms is going to be how many terms there are divided by 2. 2 times the first term plus n minus 1 times the common difference. So that's the formula I'm going to be using. Okay, so we actually know that we want n to be equal to 100. We want to sum together 100 terms. So using this formula, I'm going to go S with an n value of 100, hanging that subscript right into the n position, and then using it again right here. So 100 divided by 2, and then I'm going to go 2 times the first term, which is visible in the above sequence. It's 14. And then I'm going to go on to complete this formula. The n value, once again, is 100. The formula goes on to say subtract 1. And then multiply it by the common difference. The common difference is also very visible. To go, just go 16 minus 14, and that common difference is 2. Notice that it's always 2. 18 minus 16, 2. 20 minus 18, 2. So that common difference is 2, so that would go right there in the formula. And now you're ready to find the sum of the first 100 terms, even though you can't see them, which was the case here as well. I couldn't see all the values between this third term and this 38th term, but I was still able to add all of them based on the patterns of the arithmetic sequence and knowing specific values, such as the n value and the d value. The summation formula requires specific things depending on which one you decide to use. And I decided to use n over 2. This was the n value in the last problem. I needed the first one and the last one, and I had those things in the last problem, but it turns out that I didn't have those same exact things in this problem, which is why I switched over to this formula. Okay, here's me plugging in the numbers, and now let's simplify. So we have 50 out front. 2 times 14, 28. 100 minus 1, 99 times 2. So a little bit better looking at this point. So 50, I'm going to get one number inside the parentheses. So this is going to be 28 plus 99 times 2. So that's 50 times 226. That's just 28 plus 99 times 2 is the 226. And then multiplying 226 times 50. Get 11300. Okay, that is the sum of the first 100 numbers in the sequence. Okay, that's the final answer there. Okay, moving on to example 10. Okay, in example 10, it talks about an application problem. It says the Drury Lane Theater has 12 seats in the first row and 24 rows in all. Each successive row contains one additional seat. So let me see if I can make like a little diagram here. Okay, so row 1 has 12 seats. Let's see, theater has 12 seats in the first row. There's 24 rows altogether. So let me just try and list a little bit just to get an idea of what's going on here. Each successive row contains one additional seat. So if you're in row 2, then you're doing 13 seats. If you're in row 3, then you have one more than the row before it. If you're into row 4, you have 15 seats. If you're into row 5, you have 16 seats, and so on. I guess I don't really need to keep doing that. So, and it goes on and on and on. So what you have here is a sequence. Okay, and then they're saying that we're going all the way to row 24. Okay, so when you're talking about having this value of 12 seats in row 1, that 1 means that the n value is equal to 1. And this means you have a value of 13 seats in row 2. This would be for an n value of 2. This would be for an n value of 3. This is just the value that's in that position. This would be for n equal to 4, and so on. So that when you get to row 24, you're talking about an n value of 24. This would be n equal to 24 once you get to the 24th row. Okay, so the question here is, how many seats total are in the theater if all this is occurring? 12 seats in the first row, 13 seats in the second row, 14 seats in the third row, where these n values keep changing all the way until you're at the 24th row, which I'm not going to do all the numbers between here and there because that would just be crazy. I want to know what the total number of seats are. But just like in all these other problems, we did not know all the values. I listed a few of them. 16 seats in the fifth row, 17 seats, but I'm not going to list them all the way to 24. So I do know I'm going up to an n value of 24, and I want to know the sum of all the seats in the 24 rows. So I'm trying to find the sum of all the values in the first 24 positions. So here is the formula that I'm going to be using. I can get that n value. We already said it's 24. I can tell what the value in the first position is. If I use this formula, it's 12. And again, I know this, that I'm going to the 24th row, so n would be 24. And I can also see what the common difference is from this value minus this value. This value, it's 1 all the way down. So it does have a common difference, which makes this an arithmetic sequence. This minus this is 1, this minus this is 1, and so forth. That minus that is 1. So if I wanted to know total number of seats all the way to 24 rows, I could do 24 divided by 2 for that n divided by 2. Then here I could go 2 times the value in the first row, and that would be 12. Then I can go, we're going all the way out to the 24th row, and we've already announced that this is your n value, so it would go here as well. And then the common difference between values as you go from row 1 to row 2 and row 2 to row 3 is 1. So close that up. And then let's just try to simplify this. This would be a 12 right out here. Then inside here, this would be 24 plus 23 times 1, or just 23. Okay, so this would be 12 times, let's see, this would be 47. You can do as much or as little as you want in your calculator. So 12 times 47, that would be 564. There are 564 seats in that theater. Okay, turning that application problem into an arithmetic sequence. Okay, now we get to section 12.3, where now we're going to be looking at geometric sequences. And in these problems, what happens in the list of numbers, in the sequence of numbers that you're given, is that the difference is that they have a common ratio, not a common difference. So whenever you're trying to figure out what that common ratio is, and you're going to check it at least a couple of times, what this says right here is a geometric sequence is defined recursively. In other words, finding successive terms always depends on the terms before that. So this is another kind of recursive type of sequence. And if you want to find that common ratio that occurs from one term to the next, you take any term you want and divide it by the term that comes right before it. The term in the n-1 position is the term that comes before the term in the nth position. So this just means take any term, divide it by the term right in front of it, the term that comes before it, one spot before it. The a sub 1, the first term, they sometimes call it a. That is typically given, and the r value cannot be 0. They are real numbers. The number, the first term, I've already said that, is a non-zero number, and r is called the common ratio, which I also already verbalized. Now, in the last bit of problems that we were doing from section 12.2, we were given a formula for how to find the nth term of an arithmetic sequence. Now we're talking about geometric sequences, and this will be the formula that you will use when it's a geometric sequence. So you have to establish from the get-go, especially when the problems are mixed up on a test, is it arithmetic? Because that formula, when you were finding the nth term, was a sub 1 plus n-1 times d. Now it has changed. Now it's first term times r raised up to a power of n minus 1. So if you were looking for the 15th term, you would announce it, a sub 15. You would put a 15 in here as well, minus 1. That would be the power on your common ratio, which you would have to either be given or go off to the side and find, and then the coefficient would be the first term. So I'm going to be demonstrating how to use this over and over again in several examples. Okay, so in this first group of problems, example 11 says show that the given sequence is geometric. So in this particular problem, they're trying to get at how you would find the common ratio. And you were just told on the previous page, take any term, divide it by the term that comes before it. N minus 1 is the term that comes before n. So in this problem, if this is 6 to the n, then down here would be 6 to the n minus 1. This is the form of the rule. So instead of having an n, you would have an n minus 1 for the power. Okay, so let's see, what do we have here? So let's generate some terms in this sequence. Okay, this is the rule for generating the terms in the sequence. So if you go and try to do the first term where your n value is equal to 1, and they're giving it like that, so they're just calling it s sub 1, would be 6 to a power of 1, or just 6. When you find your second term where the n value is 2, which as I said, instead of using a, they happen to be using s now. So you could call it s sub 2 also, and that would just be, here's the formula that you're using when you're finding the terms in this sequence, 6 squared, and that would be 36. So this is the first term in the sequence. This is the second term in the sequence. If you were going to find the third term in the sequence where n is equal to 3, but using this rule, it would just be 6 to the third or 216, and so on. Okay, so if you want to find a value where you're going a term in the nth position divided by the term in the previous position, you could just go 36 divided by 6. Okay, so this would just be, if I wanted to actually get a value rather than a formula that says 6 to the nth power divided by 6 to the n minus 1 power, let's go ahead and use some numbers that would stand for this. Choose a number in any position, then divide by, and maybe I'll put this down here. Let's just leave the formula here. Choose a number in any position, and then divide it, just like this says, divide it by the number in the previous position, and you get 6. So that is your R value, your common ratio. Okay, right there, 6. Okay, so when you come to fill this in, we have already done that. That's what this stands for. What is the value of the first term? Value of the first term was right here. It was also a 6. What is the value of the second term? The second term turned out to be 36. What is the value of the third term? The third term turned out to be 216. They want us to go one further. What is the fourth term? Well, that would be when n is equal to 4 in this formula. So it would be equal to 6 to the 4th, or 1,296. And that answers all questions for number 11. In problem number 12, find the indicated term of the geometric sequence. You're trying to find the 7th term. I believe I gave you a formula for finding the nth term on the previous page. Let's take a look at that one more time. And here is that formula. Finding the nth term for anything that's in a geometric sequence, which will just be something that has a common ratio. Make sure that it has those characteristics before you start finding the nth term in this manner. So first term times r raised up to a power of n minus 1. nth term is a sub 1 times r raised up to a power of n minus 1. Okay, so if you are going to use this formula to find the 7th term, then you're going to need to know what the r value is. We can already see what the first term is. It's just 2. So it's 2. And then this would be the r value. Okay, here's how you find the r value. Take any term you want after the first term and divide it by the term in front of it. So the term in front of this would be 2. Now you can do that in your calculator for sure if that's what you want to do, but you can also easily do it right here on paper. 1/2 divided by 2 over 1 is the same thing as 1/2 times the reciprocal of the divisor. Reciprocal of 2 is 1/2. Therefore, your r value is 1/4. So I sometimes refer to that as float and flip. Float this to the top, flip it over, noting it as the reciprocal. Therefore, this is not here anymore. And when you do the multiplication, top times top, bottom times bottom, you get a more simplified value for this complex fraction. So that would be the r value right there. Okay, with that r value, I can continue this problem. I was looking for the 7th term. That's the question here. So the n value is 7. The r value is what I needed. I went to the side and got that. And now let's continue with the n value. I announced here that it was 7. So put a 7 there as well. So now you're just going to the 1/4 raised to a power of 6. So let's go ahead and put that in the calculator. Okay, so let's see, what do we have here? Let me make sure that everything I have is correct. Okay, so here we go. So 2 times 1 divided by 4, close that up, raise it to a power of 6, and then just hit enter. I don't know if it'll, it's just going to keep giving it to you in scientific notation. Okay, so you know, it's up to you how you want to put this, but let's see if I can get, I would love to show you the steps in between instead of jumping to that. So let's see if I can maybe even do it like this, 1/4 raised to the power of 6. I don't know if it'll take that either, but 1 divided by 4 raised to the power of 6. Oh, still going to give it to you in scientific notation. Let's see, math, enter, I don't think it will. Okay. So this is the same thing as 2 times 1/4096, which the only way that I know that is because 4 to the 6th power, if you put that in your calculator, just so I can show you the intermediate steps if you do want to do part of it by hand. Just 4 to the 6th power is where I got this. 2 times this would be 2 over 2 divided by 4096. In other words, 2 is the same thing as 2 times 1. Top times top, bottom times bottom would be this fraction. And then you could give a more reduced answer without it being in scientific notation. So just going in the back door there. 2 divided by 4096. Math, enter, enter. Oops. Took me right back to that again. I don't know why it's not giving me that, but this reduces to 1 divided by 2048. Mess around with my calculator just for a second. Mode. I'll take this into function. Oh, let's see, mode. Okay, so can't get it to go out of scientific notation. So 1 divided by 2048. That's how it is in reduced form. 4 raised to a power 6 is 4096. I'm just showing you where I got this. 4 to a power 6 was this on the bottom. And 2 goes into the top twice, and then I guess I did that by hand. I probably just went divided by 2. I couldn't get the calculator to do it. Got stubborn there and got 1 over 2048. Okay, so that's the final answer there. I found the R first, and then in order to find the nth term, which required this R, I then had that, and I was looking for the 7th term, which made 7 go here as well as here. Okay, moving to example 13. Okay, in example 13, it says, write a formula for the nth term of the following geometric sequence. So in problem number 13, I'm looking at a sequence of numbers that they have spelled out for us. They're wanting a formula for the nth term, so let's just recall that that formula for the nth term is a sub n, first term, times r raised up to a power of n minus 1. And we're going to create our own formula looking at the sequence of numbers that has just occurred here. Let's go ahead and find that common ratio, and you can find it in 2 ways. If you were to multiply this number right here by negative 1/3, it would turn it into 2/3. If you were to multiply 2/3 again times negative 1/3, it would turn it into negative 2/9, and so on. If you were to multiply this times negative 1/3, you would end up with positive 2 over 27. Or you can just use the formula for finding the common ratio. Take any term you want in this sequence and divide it by the term in front of it. So that would be a sub n over a sub n minus 1. That's the official formula, but you're going to get the same answer here. You're going to get a negative 1/3 because that's what it takes to, as a multiplier, if you multiply that by negative 1/3, you would get this, and so on down the line. So taking any term, I'm going to work with this one. And then I'm going to divide it by the term right in front of it. Negative 2. As I was saying, you can reduce this by leaving the 2/3 the way it is at the top and then just floating this and using the reciprocal. Float it to the top, but use the reciprocal. Using a reciprocal does not mean do away with the sign. So that negative 2 is now up at the top, being reported as a reciprocal. And when you go into multiplying those two, the 2's cancel out, leaving you with the negative 1/3 that I had already pointed out just by observation. So that R value, you can just look at, hey, what does this need to be multiplied to turn it into this? And is that same value being used as a multiplier to create each successive term? And you're going to see it's the same R value that you get if you use the formula for finding the common ratio. Okay, so now coming up with a generic formula for the nth term, and they've given you these blank spots here, but just use this formula. Okay, so they're calling it the nth term, that's this. Then follow this formula here. You want the first term in this position. So the first term would be negative 2. Then in this box right here, it would be the R value raised up to a power of n minus 1. They already have the power of n minus 1, so you just need to put your R value in here, which is negative 1/3. And that's it for that problem. Example 14, find the nth term of a geometric sequence described below, where R is the common ratio. And they've already given you the common ratio right here, and they've already given you the 5th term. Okay, so you're missing some, specific things that you need, such as the first term, but we can work it backwards. to find the first term. Okay, let's say that the 16 is right here, and this is the value in the 5th position. We can go back to the 4th, 3rd, 2nd, and 1st position, because the value in the 1st position is needed to find the formula for the nth term. So you're kind of going backwards with your thinking. Okay, so if the common ratio is -2, just ask yourself, what needs to be multiplied? What needs to be multiplied by -2, that common ratio, in order to get 16? That would have to be -8. Okay, and -8, you see that if you went -8 times -2, you would get a 16. Okay, so this number that's before it, again, what needs to be multiplied by -2 in order to get -8? 4. So I'm just working backwards. What needs to be multiplied by -2 to get 4? -2. And what needs to be multiplied by -2 to get this? 1. Okay, notice that as I multiply by -2, I get this. When I multiply by -2, I get this. So it's the same common ratio all the way down. And it should be, because if it's not like that, it's not a geometric sequence, and therefore you can't use the formula for finding the nth term, which does happen to be, I'll just remind you, is the first term needed that, there's a 1 in the 1st position, times the r value raised to a power of n minus 1. So in the end here, the formula is 1 for this value right here, and then the r value was given, which is how I was able to move from the 5th term backwards to the 1st term, which was required for this formula, and then raised to a power of n minus 1. Okay, moving to number 15, and starting in number 15, they're going to be asking you about finding the sum of the terms in a geometric sequence. There will be some problems like that from 15 to 20. And this is how you find the sum. Remember that we did a lot of finding formulas for the nth term when we were doing arithmetic sequences in 12.2, but then we switched over to finding the sum of, let's say, the first 50 terms or the first 100 terms for the arithmetic sequences, and now we're doing it for the geometric sequences. So same type of question, only a different formula when you're working with geometric sequences and being asked to find the sum. Okay, so formula that you're going to be using for a geometric sequence to find the sum of a specific number of terms, that is going to be right here. Sum of a specific number of terms where you actually know the n value. Okay, so we will hit some questions like that. Okay, and then sometimes what you're going to have is you're going to have a geometric sequence, a geometric list of numbers that goes on and on and on. This formula that I introduced right here is when you know exactly how many terms are in the sequence. Like if I was to tell you, find the sum of the first 100 terms, like you were asked that same type question in section 12.2, where you knew what the n value is. And sometimes the number of terms, you can't determine what n is because it just goes on and on and on. So what you're looking at here is there a way to find the sum when the sequence goes on and on and on? So for a finite sum, the rule is this. If the r value, remember the r value is common ratio, if that common ratio is some number less than 1, then the infinite geometric series, we say that it converges as long as the R value, absolute value of the R value is less than 1, and you can find the sum when it converges. Again, you tell that it converges to a specific value, and that value is its sum, and it can be calculated like this. Okay, so the sum is calculated like this, but you cannot find this sum if it doesn't converge, and this is how you tell whether it converges. So there is some of this definition, they go speaking about this up at the top of the page. If this finite sum approaches a number L as n goes to infinity, then the infinite geometric series converges to that number, and that value is called the sum of the infinite geometric series, and then this is how to get it. Okay, make sure you're checking to see whether it converges by checking this, and if it does, then you can find the sum. Okay, in example 15, this says, determine whether the infinite geometric series, notice that it goes on and on and on, and you do not see what the last term is. You don't know how many terms are there, none of that. So this is infinite. Does it converge or does it diverge? It's all about figuring out the R value and seeing whether or not it's less than 1. If it's less than 1, you may find the sum. If it converges, find the sum. Okay, so let's see. R value for a geometric series is always found like this, as I've shown in a bunch of previous problems. So just take any term and divide it by the number that's in front of it. So easy enough in this specific problem, it's just 1/9. That is your R value. Okay, in this problem, after finding that R value, and you can see it here, if you went from here to here, what would you have to multiply this 1 by to get to the next value in the sequence? 1/9. What would you have to multiply 1/9 by to get to 1/81? 1/9. So as stated, I want you to understand that you can see the R value here, but you can also calculate it using the formula. Okay, so the question was, does it converge or does it diverge? It converges when the R value is less than 1. So anything equal or greater than 1, it diverges, and therefore you can't find the sum when it diverges. Okay, so just to be clear, you can find the sum if it converges, which you tell by making sure that R, absolute value of R, is less than 1. If the R value is greater than or equal to 1, it diverges. No sum can be found in that particular case. Okay, so let's see. So for number 15, we see that this R value is equal to 1/9, which is most definitely less than 1, therefore it converges. And when it converges, we can find the sum. And the sum is given in this manner. Here's the formula right here. It's a sub 1, and this is just the summation notation. It says the sum of any amount of terms from 1 to infinity, so for an infinite series, and this is the most simplified version of that formula. The first term divided by 1 minus the ratio. So we're using that. First term in this sequence is a 1, and then on the bottom we're going 1 minus 1/9. And you can get your calculator to help out with that. This minus this, 9/9 minus 1/9, but again, just put in your calculator, 1 minus 1/9, and then convert it into a fraction. If you want to do this by hand or do it by calculator, you can go 1 divided by 8/9, but then don't. If you're going to put it in the calculator, you can just press it in just like this, but then turn it back into a fraction by hitting math, not equal sign, math, enter, enter. You can also do it by hand if you want. 1 divided by 8 divided by 9. Math, enter. 9/8. Okay, so that's the final answer. If you want to do this by hand, just float it to the top, flip it over, and you'll also get 9/8. Okay, so there is the sum of that converging infinite geometric series. Okay, number 16, determine whether the infinite geometric series converges or diverges. If it converges, find its sum. So in problem number 16, we see very first term is 8, then 20, then 50, then 125. So I'm going to go ahead and find the ratio by just picking any of these terms. I just like to stick with the small ones. 20 divided by the term in front of it. And remember, for it to be a geometric series, it's got to have common ratio each time, which it does, no matter what 2 you use. If you went 50 divided by 20, you're going to get 5/2. If you go 20 divided by 8, you're going to get 5/2 if you reduce it. So you could just put that in your calculator, 12 divided by 8, and hit math, enter, and you get 5/2. So this is the common ratio, but remember what we talked about up here, that if the common ratio is less than 1, that means it converges, and therefore you can find the sum of that infinite geometric series. However, this R value is not. Write it like this. It's not very clear the way I'm writing it. This R value is 5/2, and that just isn't less than 1. So therefore, this particular sequence diverges. Whenever the R value is not less than 1, so there is no sum. You cannot find the sum. Converges means that it eventually reaches a particular value, and that particular value is the sum. Okay, moving to example 17. We now have another sequence here represented by 7n squared. This will generate the terms in the geometric sequence, and then you can decide whether it is arithmetic or geometric. And they ask like several questions here. So I would first generate some terms in the sequence. If you're working with 7n squared, let's say you're trying to find the very first term in the sequence where the n value is equal to 1, then that just means put a 1 right in here. So that would be 7 times 1 squared. I can put that right here, or just 7. That would be the value in the first position. If you're looking for the value in the second position where n is equal to 2, then you're talking 7 times 2 squared. That would be 4 times 7, or 28 as the value in the second position. If you were going to find, I'll just find a few of them. If you're doing the value in the third position, that means n is equal to 3 in the rule that's being used to generate the terms in the sequence. So this would be 7 times 3 squared, which would be 9 times 7, or 63. Okay, so I listed a few of them. Okay, and it goes on. Okay, so the question here is, what type of sequence is this? Is it arithmetic or is it geometric? Now that I've listed some of the terms in the sequence, I can check whether it's arithmetic. If it's arithmetic, it'll have a common difference. Let's see if it does. Is there a common difference? In other words, when you take this and subtract this, you get 21. When you go 63 and subtract 28, you sure don't get the same common difference. So common difference, there is none. It cannot be arithmetic. Is it geometric? Well, if it's geometric, then you should have a common ratio all the way down. So let's see what the ratio is if I go 28 divided by 7. So I'm just testing this out, really not sure if it's going to be the same one all the way down, because if it's not, then it's not geometric either. So here's one way to figure out what the ratio is. Just take 28 divided by 7. You get a 4. Is that what you get when you do the next two terms, 63 divided by 28? Well, this time you definitely don't get 4. 63 divided by 28, you can just see that that's not the same thing. So since this is not equal to this, you do not have a common ratio between successive terms. So common ratio, there was none. So it's not geometric either. So it is neither arithmetic nor geometric. Okay, so there is no common difference, nor is there a common ratio. That would be the answer there. And then for the next question, select the correct choice and fill in any answer boxes in your choice. The sum of the first 50 terms, you cannot get it because you can't get the sum because it's not arithmetic nor is it geometric. So don't bother trying to find the sum. Okay, because there's no formula you could use. You've only been taught formulas for finding the sum for arithmetic and geometric sequences, so that's why it doesn't make sense to try and find the sum. Okay, moving on to example 18. Determine whether the given sequence, once again, is arithmetic, geometric, or neither. If the sequence is arithmetic, find the common difference. If it's geometric, find the common ratio as your proof that it is one or the other. And then find the sum using the formula for whatever kind of sequence it is, if it is a specific type of sequence. So here is the rule that we're going to be using to generate some terms in the sequence. So again, if I'm looking for the first term, that means I'm letting n be equal to 1 in this formula. So it would be 9 minus 7/10 times 1. Or just 9 minus 7/10. So we can put that right in here. 9 minus 7 divided by 10. Math, enter, 83 over 10. That would be the value in the first position. Okay, if I was going to find the value in the second position where n is equal to 2, then I'd be using this same formula. 9 minus 7/10 times 2. So that would be 9 minus 14/10. 9 minus 14/10. Math, enter, to get it to combine common denominators. So 38 over 5 for the value in the second position. So I found the value in the first position, found the value in the second position. I'm going to find one more. Third position, that means n is equal to 3. So that would be using this formula again, 9 minus 7/10 with a 3 here. So that would be 9 minus 21 over 10. Oops, I wanted to keep them as fractions. 69 over 10. Let me move this down a little bit so I have some room to write it. That was 69 over 10. That was my third term. It's the third term where I allowed n to be equal to 3. Okay. Now I'm going to decide whether this is arithmetic or geometric. If it's arithmetic, it has a common difference. So you can just go ahead and pop those in the calculator. Go this minus this, and then try doing this one minus this one to see if they have a common difference. So 38 over 5 minus the one in front of it. Okay, I got negative 7/10. Let's see if I get the same thing again. 69 divided by 10. minus the one in front of it, 38 divided by 5. Oops. Oh, I got the same thing. So there is a common difference, which I discovered by checking it out a couple of times, and that common difference is negative 7/10. Each time I subtract, I get 7/10. Therefore, it is arithmetic. The value of the common ratio is negative 7/10. Oh, I put it in the wrong spot. It's supposed to be common difference, so this doesn't go here. Common ratios are for geometric sequence. So common difference was negative 7/10. Okay. Then select the correct choice below. Fill in any answered boxes in your choice. So this time we can find a sum because we can actually pick a formula. The one for arithmetic summation, and that formula is the following. So when you're doing this sum, you're going to be using this formula. Okay, so I chose that. I put that in there. Okay, that's all I have left to find is the summation. So the sum, I'm going to use the formula where you know the common difference and the first term, because I don't actually know what the last term is, because how far out am I going to go? I could go and find the 50th term, but I could, you know, just as easily use this formula right here, where, you know, the number of terms would be going out to, and let me write this more specifically, we are finding the sum of the first 50 terms, which means that's going to be 50, and then the formula goes like this, that you can multiply 2 times the first term. We definitely know the first term. We at least did that in our sequence. And then number of terms would be 50 once again. We definitely know the common difference because we were asked that previously. So this would work nicely for the sum of the first 50 terms. So 50 divided by 2. Then here we could go 2 times the first term, which is 83 over 10. And then we can go 50 minus 1 times that common difference, and the common difference was negative 7/10. So a lot of stuff to put in, even if you're using a calculator. Got to be careful here. Okay, so let's start trying to simplify this. So if I was to go 2 times 83 over 10, that would just be same thing as 2 over 1. I got a 25 out here to try and simplify that a bit. This times this is 166 over 10 to take it to just a single fraction. And then this would be 49, or 49 over 1 times negative 7/10. So this times this would be negative, let's see, 49 times negative, so that's negative 343 over 10. And you can put it in your calculator like that, or you can, you know, make it a little cleaner and put the 2 fractions together, because your calculator most definitely will do that and give you like a single fraction here. And you don't even have to get common denominators because it's going to do it for you. 166 divided by 10 minus 343 divided by 10, and then just hit math, enter, enter. So that's negative 177 over 10. Last thing you need to do is multiply by 25 over 1. So 25 times negative 177 is equal to 4425 divided by 10. 1 times 10 is the denominator, so divided by 10, and you get negative 885. What this reduces to is negative 885. Whoops, I'm not showing you my steps, sorry. Negative 885 over 2. Okay, so this reduces to this, and that is the sum of the first 50 terms. Okay, just a couple more problems in this section. This is problem number 19. Okay, determine whether the given sequence is arithmetic, geometric, or neither. If the sequence is arithmetic, find the common difference. If it's geometric, find the common ratio. Okay, so similar to what we just did. And then we're going to find the sum of the first 50 terms. Okay, so they show you something here, the list of numbers here. So let's see. Common difference. If I was to go 12 minus -3, first time I look for the difference, it would be 15. Does it always come out to be 15? Because if it doesn't, if it's not consistent, then it is not arithmetic. So I could go -48, and I think you can already see what's going to happen. This term minus this term, but this time the common difference comes out to be -60. Therefore, because that difference is not consistent, here it came out 15, here it came out -60, it's not arithmetic. So it's not that. It might be geometric, so let's go and check out the common difference. There was none. Okay, common ratio, I can try that one. Can make sure, check it at least a couple of times. So I can take this divided by this. Turns out to be -4. Try it one more time. I can take this term, -48, and divide it by the previous term, which was 12. And again, it comes out to be -4. So we do have a common ratio. Therefore, the sequence is geometric. Okay, and since the sequence is geometric and they're asking us to find the sum, that means we're going to switch over to the summation formula for a geometric sequence rather than the one for arithmetic sequences. So we did not find a common difference, but we did find a common ratio, and that turned out to be -4. Okay, then for these questions down here, what is the sum? Well, when you're finding the sum of the first 50 terms and you know it's geometric, then you are using this formula. Sum of the first 50 terms is the first term times 1 minus r raised up to a power of n over 1 minus r as your denominator. So this would be the first term. This is a sub 1 right here, -3. Then you're going to go 1 minus the r value. The r value was -4 raised up to a power of 50 because we are finding the sum of the first 50 terms. So that n value is 50. Okay, then our denominator is going to be 1 minus that r value. Okay, continuing with that. Okay, so it is, I would suggest you just put this in a calculator. This is just a lot of stuff to plug in. And it's going to be a big number because of that power, which means it's probably going to come out in scientific notation again. So let's go ahead, and I think it even says use scientific notation, use the multiplication symbol in the math palette as needed. That's information for entering it in my math. We'll round to 3 decimal places. So we know we can round to 3 decimal places, and that is probably going to come out in scientific notation. Okay, so here we go, entering it just like we see it right here. So negative 3, then in parentheses I'm going to go 1 minus, I'm going to put that base because I want the negative as well as the number to be raised to 50. That's why I'm putting it in its own parenthesis. So extra parenthesis, put a negative 4 in there, raise it up to a power of 50. Now close that parenthesis so that this matches this. And then we're dividing by 1 minus negative 4. That's just 5, so divided by 5. Oops, darn, I put an extra division bar there. I'm going to have to enter it again. So negative 3, open up the parentheses, 1 minus, put the negative 4 in parentheses, raised up to power of 50, close it, that should be okay, divided by 5. And we got something in scientific notation. This means times 10 to the 29th power, and we're rounding off this coefficient to 3 decimal places, so 7.606. 7.606 times 10, that's what this E means, to a power of 29. Okay, and that would be your answer there. Okay. Okay, moving on now to the last problem, thank goodness. Use a graphing utility to find the sum of the geometric sequence. This is the rule that generates the individual terms. And we're going from the first term, plugging in a 1 right here, all the way to the 15th term. But instead of listing all the terms, I'm going to give you some practice here in getting the calculator to generate the sum for this particular rule. So right here I have listed the calculator strokes for you. First thing you're going to do is put your mode in sequence. That'll change everything to an N. Okay, so just go mode. Here's the mode key right here. And we're going to go highlight sequence. Okay, after you've made that selection, quit out of that screen, clear the screen completely. And now we're going to enter it based on these steps right here. Okay, so let's see if I can get you to see the steps while I'm pressing them in. Okay, so calculator strokes. You can be looking at your outline. I'm going to demonstrate them on the calculator. Okay, so the first thing that you're going to do, we already did pressing the mode into, putting the mode in sequence form. Then we're going to press second stat, okay, second stat, and then we're going to go over to math. Okay, once you're in math, you're going to choose option 5, which you can just type in a 5 if you want, like that, and it'll select sum. Then you're going to press second stat again, second stat, and this time you're going to go over to operations, and once again you're going to choose option 5, which is a sequence. You're doing the sum of a sequence. So I'm just going to press 5. So you're doing the sum of a whole sequence of numbers. Remember the sequence, there was even the rule on your paper, and you were going from the first value to the 15th value, but this will do all of it by way of the calculator. Okay, so now you have sum, comma, sequence, sum, parenthesis, sequence, parenthesis, and the rule for getting your calculator to do this is you have to enter the function rule, which was this right here, 8 over 13 raised to a power of n. So because the base is a fraction, it needs its own set of parentheses. So special pair of parentheses for 8 divided by 13 as a base, raised to a power of, hit the key that has the x, the t, the theta, and the n, and it'll put a power of n, then comma, comma is right next to the x squared. Now you're going to tell it what the variable is in this rule. It is an n. Once again, press the key with the xt, theta, and n. Another comma. Tell it that you're going to spin from the first term all the way to the 15th term. Another comma. We're going all the way to the 15th term using this rule, and each time the term is generated by your calculator, it's going to continue summing them together. So make sure that you have the same number of parentheses on the end of this as you do at the beginning. You have 1, 2, 3. So going back the other way, you already have that parenthesis. You need a couple more. Okay, press enter, and there you go. So it has approximated the summation for all the 15 terms generated by this rule here. So it generated all the terms, and it also added all of them together. And this is what it came out to be. 1.5989. You are rounding in this particular problem to the third decimal place. So 1.599. Okay, that concludes the lecture video for sections 12.2 and 12.3.